This podcast is brought to you by LMU Munich.
I think we need to make a warm applause for Rachel.
Well, thank you. I'd just like to say how delighted I am to be the first speaker at what looks like it's going to be an amazing conference. So thank you for inviting me. And Guten Morgen, München. Don't worry, that's going to be the last of my attempt to speak German. It's not one of my languages. Python is my language. So this is who I am. I am, at the moment, a freelance developer. I have been many things, including a founder of a startup. But I've been, at the moment, I do full-stack development, I do DevOps. I'm a Google developer expert for Firebase, which I'm going to mention a bit later because that's a real-time database. Been a keynote at various PyCons, and it's terrific to be here. I'm going to be the co-host of the Turing Festival's engineering track later in the year, hoping to do a lightning talk about that later. And 20 years ago, I was that. And if you're wondering why I don't look like that, I have to tell you, I didn't look like that then either. It's amazing what a good photographer can do. But that's when I had my digital cash startup, which was a brilliant idea 20 years too early. So I didn't make my fortune with that, and which is why I'm now a freelance developer. So what this talk is, the title of the talk is Real-Time Data with Django, and I want to talk about why I care about real-time data, why it's important, and why I'm very excited about Django Channels. But it's not going to be a talk about Django Channels. If you are actually interested in that particular technology, I'd like to bring your attention to the workshop that's happening here at 10:30 in the Gamma Room, where you can find out in detail about what Django Channels actually is. I'm going to tell you my story and why I care about Django Channels and real-time data, and I'm going to finish with a little bit of a comparison with Firebase, which is one of the other real-time technologies I know a bit about. And along the way, I'm going to go through a bit of internet programming history. Now, who in the room was born after 1986? Okay, I have been programming the internet since before you were born. So, 1987. That is 30 years ago. 30 years ago. I have to think about that. So back then, this is when I took on my second job, and I was lucky enough to fall in with a company which was doing some interesting work, doing file sharing over this new thing called the internet. And back then, everything was text-based, or file sharing. The internet was a very slow technology. To do email, which was the really exciting thing at the time, you basically had to prove that you were worthy to receive it by working out how to formulate your own personal UUCP hash network name so that you could then do a dial-up once a day to get your mail and send it on again. It was a really fascinating time. And then by about 97, we moved on to desktop. So the network was a bit faster by this point, and this is about the time when the internet became publicly accessible. In the UK, you could buy a dial-up account for about 10 quid a month. So then we were having desktop stuff. By this point, the web had actually been invented. 2007, websites were the big thing. Websites were replacing desktop apps. And where we are now is mobile apps, rich hybrid stuff. And in 10 years' time, who knows what's going to happen. But the big common theme about all of these changes with how we are programming the internet is it's all about communication. And the form of the communication may change, but the basic thing we're trying to do doesn't. We're trying to communicate with each other, either our thoughts, our words, our files, our pictures. It's communication is what it's all about. Now, why does that matter? Oh, no, first, let me tell you about Python, where Python fits in with this, just to put some contextual history in all of this. So, back in 1987, we didn't have Python. It was a sad time. Python did not yet exist. And 1991, Python came along. When the desktop apps started moving towards the websites, we suddenly started getting Django, we started having Ajax. Now a lot of those Ajax-driven websites are using REST APIs, so Django REST Framework came along. And now in 2017, Django Channels is the new big thing. So the old way of doing it was a very old-fashioned protocol called HTTP 0.9, and you basically put a request out, you got a response back. You sent a request out, you got a response back, which was fine for doing email, and it was fine for doing FTP, but it's not much good for doing the new kind of apps that we want to do. So the new stuff, we've got WebSockets. And what WebSockets gives us is the ability to set up a permanent connection where the data can flow in both directions. So, why might you care about that? Well, the nature of the kind of apps that we're building now are data-driven. And in many cases, it's things like timetables, it's things like share prices. If you're looking at a continuous integration pipeline, it's where the bottlenecks are. It's chat, like the Telegram app. It's changes to a conference schedule. It's where are we going for beer tonight. These kind of things are all about data, specific data. So these are the kind of things which are becoming commonplace now. Notifications, chat, broadcasts, and it's all about getting that data updated. Now, why I care about it is when I'm not being a freelance developer, I'm working on this side project, LuzMe, which is, in my opinion, the world's best ebook search site. At least it will be when I get it back online again, because it's offline right at the moment, because I'm upgrading it to do Django Channels. But what this is, it's a project I started about 7 years ago, and it was originally Django, single database, single Apache web server, and it's now turned into a fairly complicated distributed system, which is running on about 35 nodes in about 6 countries. And why I specifically care about real-time data, and why this has been the subject of pretty much every talk I've given over the last 3 years, is because the way I originally developed it was the way that you had to originally develop those things at the time, which is a request for data, a response with some data. Now, the nature of search engine is I don't know what you're going to look for before you actually do it. So I need to be able to respond to your search very quickly. You come to the site, this kicks off searches at the vendors, I get that data, I need to give it back to you. But there's no point me knowing about the updates to that data in the central database if I'm not sharing that information with you, my user. So I have to get this data to you. The old way of doing it is continual requests and responses. Have I got more data? Have I got more data? And that crashes the database. And it's a really, really bad way of doing it. But that's the old way that you had to. So what I have been searching for about 3 or 4 years is a good solution for putting real-time data in this playground of mine. So my original idea was to use Meteor. I don't know if anybody of you have tried Meteor. I got very excited about that, but then it became clear that it just couldn't do some of the things I needed it to do. And then, if you'd heard me talking last year at any tech conference, it would probably have been Firebase I was talking about, which is a Google technology, it's tremendous, don't get me wrong. I love Firebase, but it's got one slight downside, which is to use it at scale, you have to actually pay for the service. Now, this is a side project, it doesn't make money, I can't afford to pay much for the service. So, although Firebase is great, I have been waiting and praying that something like Django Channels would come along so I could just have a Django-based solution. And now it's here. So what is it? I'm not going to go into huge detail about it, but these are the key things I'd like you to think about. The stuff that's in blue and grey, the stuff that's in blue is what Django looks like now in the core. So you've got a web server, you've got users. Now those users might be mobile, there might be browser, there might be another server, but it's a very basic, simple request-response type thing. Now what Django Channels adds to that is the ability to have WebSocket users and to scale it out. And the whole point of adding channels in is to enable you to scale the data side of what you're doing in a Django-based app enormously. got 5 components. If you're interested about this, go to the workshop or come and talk to me. I'm here until tomorrow. But these are the key things. It's an official project. It's not yet part of the official core, but it is being funded by Mozilla. It is being supported by Django, and one of the core developers on it is Andrew Godwin, who I believe was responsible for the migrations part of Django. It's going to become part of core at some point, but at the moment it's officially supported, just not inside the core. Right, so I love channels. I got it working very, very quickly. It's tremendous. But now what? Okay, that was the easy bit. Making channels work at all. It's just follow the instructions, and it's terrific. But this is where I hit the big problem. I have a legacy project here. When I started writing LOSME, I didn't intend it to be a legacy project, but that's what it's become because it's 7 or 8 years old. So now what I have to do is to change the old way I developed it into a new way which copes with asynchronous code and which copes with the concept of using the new front-end technologies. And again, we have a talk at this conference about the front-end technologies, I think, again, which follows this one, which I'm going to be very interested in seeing what experiences they've had with it. Because for me, this has been the hardest part of the project, is putting a new front end on the old code. Because without putting that front end on, I couldn't take advantage of the asynchronicity of channels, which meant I couldn't use it properly. So in my case, what I've had to do is throw away the old Bootstrap version, and I'm building a new React-based front end, which is why the site's offline at the moment, because this is taking a little longer than I'd hoped. And why I needed to do that, the way that Channels works, you sit there and you wait for these messages to come in, and what Django Channels is doing very easily is pushing out those messages through the WebSocket interface to tell you about the data that's coming to you. The challenge is to do something with it, and that's where the asynchronicity in the framework is needed. And then the other problem is the tool chain is completely different once you start going from, if you start using something like React, or you start using what's the other one I used to use? Angular, any of those sort of things. It's a just totally different way of doing it if you haven't already got your backends set up to do asynchronous data. So I had to make a lot of choices. And it all comes back to the data. And the reason why you have to put some real effort into the data is it's not just the concept of how you take the data from your database and distribute it. What you have to think about, which is where the network programming comes back in, is what kind of network are your users going to have? What are the choices that you can make that gets them the best data in the most efficient manner? And what does efficient actually mean in that context? For example, if you're sitting here in a university computing department, it's quite likely you're going to have high-speed Wi-Fi, or you're going to be able to tap into some really high-speed wired network connection. If, on the other hand, what you're trying to target as your app is an application, for, let's say, for walkers in Scotland, where I live, you can't actually rely on there even being a 3G mobile signal out in the hills of the Highlands. You don't have to go very far from my house in the centre of Edinburgh to not have any mobile data connection at all. Or if you have, it's going to come and it's going to go. So it's important that you understand what kind of application you're building, and it keeps coming back to the network. If you're going to do anything at scale that's going to be global, this is going to be the single biggest challenge you're going to have to face, is working out how to get the data you need to your users in a situation where the network is unreliable and will vary greatly, so that the user can actually benefit from your app without chewing up all of their precious data service from their mobile provider, if that's what they're using. And the world is going mobile. There's another talk that I do which has got some stats about how in some countries, like India and Africa, not Africa, but in some parts of Africa, people just don't have desktops anymore. It's not that the mobile is an addition to their internet experience, it is their internet experience. And in India, the mobile you're going to be using is not going to be an iPhone, it's going to be a very low grade, low cost, low bandwidth device, but it's whatever he's got. So if that's the audience you're targeting for your business, that's what you've got to understand how to get the data there. Now, why this matters is if you're using channels for this app, it's solved the problem of how the data is going to be pushed out across the network, but it doesn't solve the problem of how you benefit from that data particularly easily. So, the client side has changed since in the last 10 years. We've now got these different frameworks. We've got these, either raw data script, or you can be using React, you can use Angular. The tool chain has changed. If you're going into any of these things like Angular or React for the first time, you're going to discover a world of pain, because you get into a new set of religious wars. Should you use Grunt? Should you use Gulp? Should you use Browserify, Webpack? Every project that you want to build will come with a template for how to build it, and every one of them will be different. And the year after you started work, it's all going to be changed. It's all going to change. So if you're trying to do anything like I'm doing here, of retrofitting new technologies like the channels in, be prepared to put effort into this bit. And the server side has changed. Now, when I started my project, single web server, single database, single pretty much everything, part of it. Now it's distributed, so my monitoring task is huge, because although I'm running this as a side project, I use it as a technology demonstrator for when I'm aiming to get interesting freelance work, because it's much easier to be able to talk in an interview about my project where I have no commercial confidentiality to worry about than a customer's. So I like to run it as though it's a real commercial project, which means commercial grade monitoring, commercial grade logging, deployment done automatically, all the things that I like to do when I'm working for other people. So, how am I doing for time? Okay. I'm actually rattling through this a lot faster than I expected, so there's going to be plenty of time for questions, so get your questions ready for me. What Django Channels is, very easy to use, and it's really worth investigating. The workshop's going to happen immediately after this, but as I say, I'm around all today and tomorrow, so if you've got any questions, definitely ask me at the end of this talk, because we'll have time for that, but also just grab me any time later. It's the migration of the legacy code. If you're starting with a new project using this, you will find it very much easier than if you're trying to retrofit the technology into an existing project. And that's not because of any problems that Channels itself is adding, because they've put a real lot of effort into making sure that you can take existing Django code and just run it with Channels, and it will work with no changes whatsoever. It will just work. So the Django bit is easy. It's the everything else you have to plan for. I'll put these slides up on SlideShare afterwards if you're interested, and I've got some links at the end which you might like to follow up on. The migration of the legacy code is a problem which I have not yet encountered a customer who's understood what that actually means. They think it's just well, I hacked up this demo at home over the weekend. Why is it going to take a year to do this? Because they don't understand the scale of the problem and the scale of how you retrain an existing development team in some cases to change from doing it this way to doing it that way with no break of service. So if you're involved in this kind of thing, definitely get involved with doing a demonstrator project first so you can understand where the effort is going to be needed in your business to make this work as a production quality system. And the tool chain. You need to put effort into the tool chain because that's where you're going to save yourself the future world of pain. And in the ideal world, where customers of mine, they're all moving towards the idea you want to have continuous integration, continuous deployment, the idea that we used to have of you do one code release a month or even one a week. That's out the window now. I mean, one of the companies that we have in Scotland, Skyscanner, I don't know if you've heard of them, they're a massive travel search engine. They do about 3,000 code releases a day. Basically, every time somebody changes the code, it goes through the integration, test, deploy, smoke test, full deploy cycle. Every change can potentially get to live within the hour. That's the way that software development needs to go, so that then we, as software developers, can be working on the interesting problems of what we're going to do with the technology and not how do we actually do anything at all. So with Django, I don't know if you've come across the cookie cutter project. Very worthwhile looking at. It's from the people who wrote the 2 Scoops of Django book. They've come up with a cookie cutter way of producing the whole tool chain for a complete Django project, which includes all the things like Webpack for the front end and React or Angular. Really worth looking at, but none of them work out of the box. You have to put your own variant in it. For example, I don't want to use Postgres, I want to use MySQL. I don't want to use Bootstrap, I want to use Foundation. So I've had to take their cookie cutter project and modify it so that it matches what I like to roll out for a new project. But once you have that, it's great, because if somebody comes to me and says, look, I need to make a new demonstrator, can you put this together for me? It's a completely new project. I can just go, yep, new project, and I get the whole tool chain already there for me, built in the way that I understand how to use. But I had put effort into working that out, what works for me and what I want. So getting back to Django Channels, which was the point of the talk originally when I started writing it. What it allows you to do is to do asynchronous Django at huge scale. It's doing that because it's adding in the idea of having web workers, so your server is automatically being able to push work off to these asynchronous workers via a Redis database, which means that potentially this can scale up as large as you need. It lets you do authentication with the standard Django, which is really important if you've got an existing system. And it gives you distributed workers without needing to use Celery. Now, I use Celery a lot. It's the messaging queue of my choice. It's terrific. Sometimes it's a little bit heavyweight for what you need. If all you want to do is a little bit of work or a slow task done outside of your web server, then this can give you that very easily. And it's, as I say, it's a drop-in replacement for the existing code that you've got. But what it doesn't do, this is where the effort has to get put in if you're going to do anything real with it. It doesn't give you persistence in the WebSockets. So somehow you have to keep that WebSocket alive if it's dropped. For example, if you're going through the tunnel outside Edinburgh Waverley Station. It doesn't give you the ability to do offline sync either, which is another facet of what happens when you're doing data in an unreliable network. And you have to assume that the network is unreliable because at some point they always are. And in most cases, they usually are. So what I mean by offline sync is, say for example, you are on this train and it's going through the tunnel and you're going to lose your connection and you're right in the middle of doing, say, a bank transfer. You don't want it to drop completely the state that you're in. What you need to be able to do is build in the local storage of that transaction in its current state. And the server side needs to understand what state it was in and have a mechanism for putting them back together again. Channels itself doesn't do that. Nor, at the moment, does it provide client libraries or documentation to tell you how to connect up to something like React or Angular, which is, I'm hoping, is one of the things we can improve on it for the future. I certainly intend to contribute back what I've learned with doing React in the future to make this easier. But this is where I had to put a lot of time into taking the raw example they gave of a raw socket and turn it into something I can use. And I'm going to finish by talking about the comparison with Firebase. So, Firebase is when Firebase was originally built, it was just a real-time database, and then Google bought them. So now Firebase is part of their entire mobile app development platform. So if you're interested in doing mobile apps very quickly and having a lot of the Google world built in, it's very worth looking at. And they have 3 different sort of pricing levels. They've got a very good free hacker plan. There's a mid-range one where you can pay a fixed amount and get a fixed set of resources. And if you want to do anything at scale, then you go for the pay-as-you-go model, which is the bit which I don't like, because as a cheapskate freelancer, I don't want to put a credit card out and find that it's bankrupting me because my website hits CNET front page again. I've had this happen to me a couple of times where somebody's tweeted, or I've had an article on CNET or on Boing Boing or whatever, and suddenly my traffic level, which is normally going ding, 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 suddenly goes, whoo! Now, if my credit card was paying for that spike, I wouldn't be excited about it. I'd be going, oh my God, how am I going to pay that bill? So I don't like a pay-as-you-go model for my purposes, but if I was spending a company's money, that might be the right way to go. So, I'm not going to say that either Firebase is a good thing and Django Channels is a good thing, and one of them is better than the other. They're both very good for separate audiences, so depending on what you need. Firebase offers a quicker way to get past the pain points that I've identified with using channels, but it comes at a cost. So you can't self-host, you have to use their servers. Django Channels, you can self-host. Firebase, you have to pay at any kind of scale, although, as I say, there is the free version. Django Channels, if you're hosting it yourself, it's always free, up to whatever scale. Now, Firebase also solves these pain problems of having persistent connection. It will cope with the idea that the connection is going to come down, come back up. It's going to cope with the offline sync. And it comes with good support for the client libraries. This is when I first came across Firebase. It's why I loved it, was because I was just looking at some stuff over New Year, trying to find a solution for this real-time problem that I had. Came across their fantastic documentation, and within 2 hours I'd got something running. Problem is, though, if you want to use it with an existing database like I had, everything is in MySQL. Firebase is a NoSQL database, so if you want to use it in conjunction with an existing system, you have to then figure out how you're going to synchronize these 2 data sets and these 2 different data models, which can be done, because that's what I was doing for a year, but it adds in extra complexity and pain. And you can use Django authentication with something like Firebase, because they've got a mechanism by which you can do a third-party authentications. So it's possible to use it with, and in some cases it gives you a better, faster solution than doing Django Channels self-hosted. But at the moment I'm going, as I say, for the Channels solution, because I can just do with it anything I want. I've just got to be smart enough and put enough time into figuring out how to make it do exactly what I want. There are also plenty of other options out there. Meteor is still out there, which I think is the other big contender. So Firebase is owned by Google and self-funded. Facebook had Pars for a while, which was another of the contenders for this type of thing, but they closed that down, although they've made the source available, open source. And then Meteor has been massively venture funded, also worth looking at. But I think what I can take from the fact that all of the big players are looking at a real-time data solution is they're seeing this as a being really big part of the next generation of the web, because data is the lifeblood of what businesses are about now. And so real-time data is going to be hideously important. So these are links which I recommend you have a look at if you're interested in finding about this more, and I will tweet out the slides so you can get those links afterwards. And I believe that is it. So danke. Haben Sie Fragen?
Raise your hands. Come on.
Oh, come on.
Okay. Please, I'm not super familiar with WebSockets, so I'm sorry if this is like a no-one-solved problem. But I know it's like pretty different from load balancing traditional applications. So like, how do you load balance kind of WebSocket connections? What are your best practices?
So the question is, with WebSockets, how do you do load balancing? Is it correct? I think the way I would approach it, I don't know if there's a standard best practice, but the way I'd approach it is that you want to make the data requests as self-contained and as small as possible, so that you're not having to load balance a single large thing against a single server. You're just splitting it into lots of tiny little things, firing them all away, getting a response back in lots of different bits. So you're not load balancing by sharing the data over a fat pipe, for example. I mean, what you're doing is so with channels, for example, you've got the option of doing multiple web workers. So you can have lots of requests going into however many web servers that you're load balancing over the normal method, and then it's chucking the data off into the servers. It's not a very good answer. I haven't had that problem yet, so I don't actually know the answer. But the way I'm addressing it in my design at the moment is by just making sure that I don't have to be tied to a specific server for anything. And usually where that comes into being problems is with identity, or where you have to have state stored. If you take away the state from the specific request, then you need less to care about how the load balance is working, apart from just giving more servers that can cope. So I think it was a very good question, actually.
Okay, thank you. More questions?
Can Django channels be used without Django?
No. Although, having said that, there's 5 parts to it. There's the bits which make it Django channel specifically, you can use without Django. So it's got, rather than having the WSGI interface, you've got an ASGI server, and you've got another component which is helping share the work out. You could use those separately without Django if you wanted to. And I believe the intention is to go down the path that you might want to do that, so you can use the technologies for doing the scaling, rather than specifically for being a web server. I think that's the intention, but I don't know at the moment if it makes sense to try to do that. But in the future it might be.
So what this lines, what you're saying was that Django Channels is a drop-in replacement
Yep.
for what you currently have. But before that, you were saying that a lot of the work you're currently doing is you're replacing synchronous code with asynchronous code, and so that's a challenge for you currently. So how do these relate? Because
the existing synchronous code will just work. It just doesn't work as well as it should do in what I'm trying to design for the future. So as it stands, it will work as well as it did before. But since I'm changing the way that the front end works to use the real-time data a lot more, what I'm having to do is change the back-end work so that it doesn't do... Like you know with Django, it's a templated-based system. So normally what you do is you construct your object, which has got all of the data associated with it. You apply it to a template, and there you display the template. What you're doing with what I'm doing with an equivalent web page now is constructing a page which has lots of WebSocket connections back to the channel server, where data can be shoved forwards when I get the new data coming in. So I'm changing it from being an object which is a page to an object which is an element of the page. And so my back-end code has to change the way it constructs that data. But the existing code that created a page object and displayed it through a template still just works. It's just inefficient. It's just not what I want.
So it's kind of an incremental process that you're improving.
Yeah.
The responsiveness.
Yeah. So I'm basically re-architecting a lot of the code by choice to take advantage of the new features, but I don't have to do it. If I didn't want to do it to a particular page, like for example my About You page, I'm not going to touch that. It's going to display just the way it did before because it's a static page. I don't need the real-time data part of it. But all of the pages which are to do with price updates or new recommendations or people have upvoted this book or here's a new book list about Python, terrific books, whatever, that's all real-time data. And for that, I need to change the way I'm doing the back end. Say again, please.
Which asynchronous framework do you prefer, async.io or?
Okay, so the question is which asynchronous framework do I prefer, Twisted or async.io? I haven't used either. I like Django Channels.
Did you consider any other Django-based WebSockets?
I thought about build. The question is, did I consider any other Django-based WebSocket frameworks? And I did look at it. There's been a couple I've thought about. There's one that somebody had put some work into called Swamp Dragon, which I had a look at. And then I also thought about building it from scratch myself. And what I would have thought about building would have ended up looking a lot like Channels. I didn't do that because it's a lot of effort. And I found a solution that worked at the time, which was Firebase. And I knew at some point somebody was going to solve this problem for me. And so when they announced it, I thought, right, there's no point me even thinking about doing this. I shall wait for Channels to come along and then help support that if I can.
All right, anyone? Yeah, please.
On the slide, we had a couple of the trade-offs, especially the network trade-offs, the fast, the efficient, whatever. Can you go a little bit into the options that exist?
So the question is, on the slide I had options for like, what efficient actually means, like fast or efficient. What are the trade-offs? It depends very much on the network. It's not a simple binary choice in any case. It's understanding what kind of network your users need to be made efficient, and then looking at those options. So, for example, in a application where you're trying to share data with a poor Indian farmer, for example. I keep coming back to the Indians because their use of this kind of technology, or mobile technology, is going through the roof at the moment. What they need is to be able to have something that works, but it doesn't have to be beautiful. It doesn't have to have a lot of data being thrown, a lot of superfluous data thrown at them. What they need is the raw. They need small data, and they need it to work when the networks come and go. Whereas for somebody who's doing a stock trading app, for example, they don't care how much money they spend. They just need the data a fraction of a second faster than somebody else, so that they can make their mega bucks on front trading. So it's knowing that the trade-offs are always dependent on what you need. For example, another thing which has to be borne in mind is latency. If you only ever think about bandwidth, then latency is something which can hit you if you're not thinking about it. For example, if you just need to put a large amount of data from A to B, it doesn't matter how big the packets are, how slow it is, as long as you can keep throwing the data through it. Whereas if you're trying to do real-time gaming, then the latency of how long it's going to take for me to interact with you on the other side of the world and for that response to come back, latency really matters. Because if you don't have quick, fast latency, then you get jerky response, or you get an unplayable game, or in the case of the video, you get very jerky pixelation happening. Because some parts of the image are being applied to the screen refresh faster than others. So basically it's bandwidth, it's latency, it's price, it's reliability. Depending on what the network type is that you're working with, depends on what choices you have to make. And in some cases, what you need to be able to do is say, have different layers of engagement. For example, when I worked at the BBC a few years ago, working on an interesting project where we were re-architecting quite a lot of the internals. with the BBC, they've got a particular place in our hearts in the UK. They are the place where people go to or used to go to, for their reliable news. So, for example, you were planning for things like, there's a known event about to happen, the World Cup final's going to be on. How are we going to cope with the spike that's going to come in at half-time when everybody, when a goal gets scored and everybody wants to see the replay, and they're going to go to the BBC website and they're expecting live video coming back? That's a known thing that we can plan for. And I have to say that in terms of milestones, I got a new idea of what a milestone was when the deadline is the royal wedding. It will not move because I haven't got my code finished. But there's other things you know it's going to happen sometime, like the death of the Queen Mother. At that point, it's going to happen, but you don't know when. How are you going to plan for that spike to happen? Or the next to 9/11 or whatever, where something amazingly awful is going to happen, and everybody's going to rush to the BBC's website to find out. So one of the things you can do there is put in tiered response, saying, under normal circumstances, we expect to deliver live video. And in some cases, in live video at huge scale, like when the Olympics are on. But when you're having a situation, you might want to say, we stop the live video. We come back down to, we'll just do text. And if it's a really bad situation where half the network's gone kaput, then at that point, maybe you have to have a really low level, but the news must get through. And you plan for those events of dropping down the quality level in a planned way, because what used to be normal is not normal anymore because of external circumstances. So it's all a question of understanding as much as possible about what you need, what you've got, what might happen, what they need, what is the purpose of your business and what you're trying to get through. Then you can make the decisions about the network.
All right, Rachel. I think it's perfect timing. One more? Okay, a short one then, please.
Okay. What do you think would be the future approach to dealing with this offline sync here with sites here?
The question is, what do I think will be the future approach to dealing with the offline sync? Well, I think the default option is going to be what it is at the moment, which is there is no handling of it expected. What I expect for myself to think about is what my application needs to store offline. And the only thing that I can see as being important at the moment is if somebody wants to add a book to a wish list. That can just be local storage and then shove that through.
We're doing at the moment, we're storing the session at some Redis database when we don't get the response from the client.
I would suggest that you can continue the discussion offline because we have a next talk in 4 minutes.
Oh, okay. I do apologize.
I want to say actually it's perfect timing.
Right.
I'm surprised. Usually in the morning it's more chaotic, but that was
German efficiency.
Keynote. I think we owe a thank you to Rachel.
Okay.